Hi, everyone. Today we're going to learn how to lie with statistics, or at least how others do. Let's suppose that a pollster calls your home and asks you to answer some questions. You agree to answer the questions, and you get a question like, well, what detergent do you like, and what sports team do you like, and how many times a year do you go to parties? And then you get the question, um, would you be more or less apt to vote for candidate Taft if he learned that he sexually abused his mother? Now, that's a question, right? That should cause you pause as a critical thinker. This poll that's being taken is an example of what's called a push poll, P-U-S-H poll. The point is to push information into your mind, not to collect it from you. So you need to be aware of what you might face when somebody calls, says they're a pollster, and wants to ask you a few questions. Okay, now along this line, we're going to try to learn how to understand when a statistic is dubious, when it's not as good as it ought to be. For example, did you hear the latest statistic that 98% of all people who are not communist mother rapers favor the right of all Americans to own a machine gun? Now, do you favor the American right to own a machine gun? Okay, suppose a pollster presents that kind of information to you. They're again trying to push something into your mind, and by unfairly framing the question, they are affecting the statistic that is going to produce. The number of people, say, the statistic of the number of people who favor the American right to own a machine gun. Okay. Now, for the rest of this lecture, I'm going to present a series of examples of dubious statistics, and we're going to learn a little bit about how statistics are created and what, as critical thinkers, we need to be on the lookout for. This information comes from a book called Stat Spotting by Joel Best. And here is that book. Let me just show it to you, in case you'd ever want to read it someday. I'm going to give you just the highlights from this book. Okay. So you're surfing the web, and you come upon this claim from the website. More than 4 million women are battered to death by their husbands or boyfriends each year. American women, right? This is according to the 2014 Annual Statistical Abstract of the U.S. Now, that book is a very reliable book for statistics. So you want to believe my information, right? After all, I am the teacher. Don't you trust your teacher? No. Think about that number again. 4 million women battered to death? Do you have any sense of how many people die each year in the United States from homicides? Being battered is just one kind of homicide. The whole total is only 16,000. So that number of 4 million just cannot be right. Unfortunately, this statistic that I just gave you about the number of battered women has been repeated in other websites, and that shows one of the problems that statistics have. They're like vampires. They're as hard to kill as vampires are. Keep getting passed along. Okay, let's take another example. Example of how statistics can lie. This is a press release from the British Heart Foundation. Quote, "We know that regular exposure to secondhand smoke increases the chances of developing heart disease by around 25%. This means that for every 4 non-smokers who work in a smoking environment like a pub, one of them will suffer disability and premature death from a heart condition because of secondhand smoke." End quote. Now a pub, right? That's your British version of a tavern or a bar. This means that is in the middle of this press release, but it doesn't mean it at all. A 25% increase in your risk doesn't mean that 25% of the people are going to suffer what it is that you're risking, right? I mean, if the risk is small at 0.0000 and you increase that 25%, you're not going to get 25% of the people having the problem, but just, right? Okay, so that's the point. Take another example. Okay? This is about hyperbole or about exaggeration. When you get superlatives like the biggest, the worst, the costliest, and so forth, you want to be alert, like, okay, now, how did they collect that information? So in 9/11, September 11th, 2001, terrible disaster, terrorist disaster in the United States, and TV commentators were calling it the worst disaster in American history. Now let's think about this worst disaster in American history. American history goes back quite a ways, right? At least to 1776. What do they mean by disaster? Well, that's when a lot of people say are killed in a short amount of time. That's probably what they mean by disaster here. They haven't been exactly specific on how they measure this term disaster, but that's unlikely. Oh, that's likely what they mean. Okay, now the best estimate of the 9/11 death toll is 3,025 people. That counts the airplane crew and passengers. It counts people killed at the World Trade Center in New York City and the Pentagon. A horrific toll. I mean, only 2,403 people were killed at Pearl Harbor. Pearl Harbor is this harbor near Honolulu in Hawaii, and it was the beginning event of World War II when the Japanese bombed the American naval base in Pearl Harbor, right? But how do you measure disasters? If you're going to talk about the worst in American history, you should pay some attention to the population, because the population of the United States has changed. And a better measure of the disaster might be number of people killed per, some numbers say millions of Americans, per million people in the population. Now, if you collect that information, then you get a completely different story. On September 11th in 2001, there were 11 deaths per million Americans. It's a big number, but in Pearl Harbor, if you pay attention to the U.S. population, there were 18 deaths per million population, as opposed to the 11 for 2000, as opposed to the 11 for the 9/11 disaster. And so, on the basis of looking at the number of deaths per million, the Pearl Harbor attack was actually worse than 9/11. But wait. In 1889, the Johnstown flood killed 2,200 people. That's 36 deaths per million, because the population was so much smaller back then. That's twice as bad as Pearl Harbor, which was much worse proportional to population than the 9/11 attack. Okay, let's have a few other numbers here. The San Francisco earthquake, wide range from 6 to 40 per million. Quite terrible. In 1900, the Galveston hurricane in Texas killed somewhere between 56 and 105 million. I'm sorry, between 56 and 105 deaths per million in the population. So that's worse than all the previous disasters we've just mentioned. Then the worst of all is perhaps the Battle of Antietam in the Civil War in Maryland. And somewhere between 110 and 151 deaths occurred per million population. So by looking at deaths per million of the population, there are many disasters that were worse, unfortunately, than the 9/11 disaster. So the commentators should have said not that it's the worst disaster in American history, but that it's one of the worst, or it's the worst in recent history since World War II. Something along that line. That would have improved the statistical report quite a bit. Okay, let's take another example. This is about expanding definitions. The problem is what we call definition creep, in which the definition of a term keeps expanding so the statistic sounds worse and worse. Child abuse, for example. Originally, child abuse was understood as involving physical abuse only. But over time, this definition has expanded, and now it includes sexual abuse and emotional abuse and other abuses. So reports of child abuse that aren't sensitive to this change of definition will skew this number to sound as if it's much worse than it really is. Okay. Pardon my cat who's interrupting everybody here. Okay. Hate crimes. This is another example of a term whose definition has changed over the years and become broader. Hate crimes originally involved racial or sexual bias. That category has expanded over the years to include sexual orientation and crimes motivated by bias towards gender or disability. So, statistical estimates of the problem's size will increase just because the definition itself has increased. Now, there may be very good reasons for changing definitions. It's not like the definition shouldn't be changed, but if the original definition, say, was too narrow. But we just, as producers of statistics or as receivers of information about statistics, we should be told this so we can properly adjust. Or if you report something over time, and you use a definition for year 1, a different definition for year 2, and you get a different definition for year 3, and then go back to the first definition for year 1, it's a screwy statistic that's getting created. Now, along this line, the Secretary of Interior in 2006 released a Fish and Wildlife Service report claiming a net gain in America's wetlands for the first time since the service began compiling data in 1954. This report, prepared as part of President Bush's initiative to stem the losses of wetlands, is good news. Although the overall state of our wetlands is still precarious, this report suggests that nationwide efforts to curb losses and restore wetlands habitats are on the right track. This report immediately attracted lots of attention from conservationists, who pointed out that this increase in American wetlands came as a result of increasing the breadth of the definition of the term wetlands and no actual land that changed its character. The new definition started to include golf course water hazards and other man-made areas like this. So got quite a complaint at the time. Right? Now, people have been thinking about social problems and collecting accurate social statistics for a very long time, and we know a great deal more than we did in the past about measurement problems and how to deal with them. And courses in statistics and research methods and so forth teach people best practices, such as how to draw representative samples, how to word questions so they're not biased, you get accurate information. And ideally, when people produce statistics, they make this information available about their methods and their even the questions that were asked in their polls. And they talk about their sample sizes, their confidence intervals, and this is the proper way to present information in a way that can be well understood and you find out whether or not it's reliable. Unfortunately, when numbers get produced, sometimes that information gets lost and numbers go into circulation without this necessary information that a good critical thinker would like to have. Okay, now let's take a look at a couple statistics. Here's one that has been produced by some social scientists. The U.S. now contains 5,235,000 illegal immigrants. No comparison with previous years or predictions about future years. But it does give you some sense of the number of illegal immigrants, right? Wrong. How do they know? How do they count illegal immigrants? It's the nature of such people to hide from government officials who try to count them and identify them. Last year is another statistic. Last year, $3,400,000,000 was spent on illicit drugs. Now, as a critical thinker, when you hear that number, you should think, how'd they count that? Who's telling the government, or whoever took this statistic, how much they spent on crimes, like selling illicit drugs? So ask yourself, just how do they count these numbers when they give you these numbers? That in the back, when they give you these numbers, ask yourself, how do they count such things? Now, the format by which numbers are presented is very influential. And, what happens to your mind when you hear a statistic? So, okay, let's look at an example about avian flu, bird flu, right? During the autumn of 2005 and the early months of 2006, there was a lot of media attention given to this problem of avian flu having broken out in Southeast Asia, and perhaps it'll spread and become a global pandemic. In particular, there were warnings that the current strain of flu involving H5N1 subtype was extremely virulent, as evidenced by the fact that half the people who had been hospitalized with the disease had died. If the disease spread widely and it killed half the people who contracted it, consequences would be catastrophic, wouldn't they? A paperback called The Bird Flu Preparedness Planner warned, quote, "This is no ordinary flu virus. This new strain is highly lethal, with a death rate of 50%, 80 times the normal flu, with the potential to kill hundreds of millions given the right conditions." Now, notice how they slipped in this number, 50% death rate. That's not right. The 50% death toll was calculated on the basis of counting the number of people who went to the hospital for flu and counting the number of people who died of the flu in the hospital. Half of them who went in for that problem did die. Yes, but think of all the people who never went to the hospital. They stayed home, they suffered, they recovered, and the hospital never had any report about them. So surely when you look at, you don't compare people in the hospital as your comparison group. You want to compare everybody who gets the flu. Surely not 50% of those die, right? We don't have that number, but it's surely much smaller than 50%. So scare tactics, or some kind of mistake was made along the way here, causing these reports to be made all around the world. Okay, let's think more about this comparison group. Auto accidents, for example, are quite a problem, but if you think about it, they only count for 2% of all deaths. So if you're thinking about the problem of teens driving, you think, well, only 2% of Americans die of auto accidents, then it probably isn't such a problem for the teenager to drive, right? It is a problem. 2% isn't big enough, but it's not that big. But the problem here with that statistic is they picked the wrong comparison group. You don't want to look at all Americans. You want to look at auto accidents by teens compared to teens, not compared to all Americans. If you just look at the teens, 1/3 of the deaths of teenagers who drive car between 15 and 19, 1/3 of all those deaths are caused by auto accidents. So it is a serious problem for teenagers. Let's look at another problem here. Again, from Joel Best in StatSpot. You know what the word average means, right? Well, it's an ambiguous term, right? It can mean mean, median, mode. You've been studying these things. Here is a report from CNN. The average U.S. household has a net worth of greater than $400,000. Okay. It's a 10-year-old statistic. The average household has a net worth greater than $400,000. What do they mean by average? They're reporting the mean. If you turn to the data that they got it from, the median family net worth was only $86,000. This includes savings, the value of the property, and so forth. Now, with the median, that means that half of all the people, of the Americans, households, make less than $86,000, or at least did back in 2001. But the mean net worth is closer to $400,000. That's because when you calculate the mean, there's a lot of influence from those who are way out on the bell curve who make lots and lots of money. When you average them in, this number goes way up. Now, what would have been the best number for the CNN organization to have produced in order to give you a sense of how American households are doing? Surely not the mean. It should have been the mean. It should have been the median. Right? Or at least they should have been very careful to tell you what they meant by the word average. Okay. Here's a final example. This is from the United Nations. Their development program wanted to call attention to the global water crisis, which is a significant problem, getting good water to people in a reasonable way, and an adequate amount of water. So here's the report. It says, dripping taps in rich countries lose more water than is available each day to more than 1 billion people. Okay, so there's some kind of problem with rich countries, right? There's too much dripping going on in rich countries, right? That's what the report is saying. Now you have to ask yourself, well, what do they mean by rich countries, for example? That's a key term, rich countries, right? Is Turkey a rich country? It counts as a rich country. But then there's this other problem with the dripping. How do they know how many dripping taps there are? And how do they know how much dripping is going on? Terribly difficult to measure. So this is probably just more of a guess, any kind of accurate number. Dripping taps in rich countries lose more water than is available each day to more than 1 billion people. Water loss is a serious problem, there's no doubt about it, but watch out for that statistic. Right? It's like wildly imprecise. Okay, well, there's zillions of examples of how to lie with statistics, and we've looked at quite a number of them. Let's just summarize what we looked at and sort of get the big picture here. We started with an example about push polls, and same point that was made with the pollster who provided the statistic that 98% of all people who are not communist mother rapers favor the right of all adult Americans to own a machine gun. Okay, so that's a very blatant example. They wouldn't really do something that bad, that easily detected. But you have to be on the alert as a critical thinker for push polls in which you're presented with information that they hope you will accept as fact, when in fact it's not a fact at all. As consumers of statistical information, we need to be on the lookout for numbers that are inconsistent with other solid numbers, like the example with the 4 million American women battered to death each year by their husbands or boyfriends. Blatantly inconsistent with the fact that only 16,000 people are murdered at all in the U.S. every year. Now, if you didn't have that background number or something close to it in your head, you perhaps wouldn't be able to assess that 4 million is a large number, too large to be true. The example about getting heart disease from secondhand smoke shows us that people often make mistakes when they convert statistics into simpler language for the public. The example about 9/11 being the worst disaster in American history reminds us to be alert to terms like the worst, the biggest, the most expensive, and so forth. There's too much exaggeration going on out there. The examples about the increase of child abuse and hate crime and wetlands reminds us to watch out for definition creep, in which a term expands its range of applicability. The example about the U.S. containing 5,235,000 illegal immigrants reminds us to be on the lookout for numbers presented to us without information about the measurement choices, about how they counted this number, in other words. Perhaps they couldn't count such numbers. We do know, however, that lying is up 12% over last year. Oh, sorry. Let's get serious again here. The example about the 50% death rate from avian flu reminds us that samples are often not representative of the larger population that you want to know about. The example about teenage auto accidents reminds us that if we change the comparison group from all drivers to teenage drivers, we change the statistic in an important way. The example about a majority of women living with spouses. Oh, I didn't give you that example, did I? I was going to give you that and I left it out. Okay, what is that? That example should have been that a majority of women do live without spouses if you count 15-year-olds. But if you don't count 15-year-olds, and you wouldn't think of them perhaps as properly part of the statistic, then a majority of women do live with spouses in the United States. The example about the net worth of average households reminds us to pay attention, close attention to the difference between a median and a mean. Now, what all these examples illustrate is that people can lie with statistics, and you as a critical thinker want to have some kind of logical self-defense against this lying. And hopefully you won't use this knowledge to do your own lying, but merely to detect it in others. Okay?